Hello everyone, how's it going? So today we're going to see how we can make someone invincible, just like that. Let's see how we can do it. So let's see how we can code this. Now I have this Python file opened up and I'm calling it as invisible_man.py. Let's see how we can run this. So we will call Opencv first. Let's import Opencv first. Let's make it a little big so it's visible for you guys. So the first thing we're doing is importing Opencv. We also need NumPy for some sort of manipulations, to do some little bit of addition and subtraction of images. And we will import NumPy as NP. The first step we will do is let's open up your webcam and start reading the images out of it. So there is a video capture command function in Opencv where you can read the images from the webcam, and if you are using your default webcam you can put down 0. If you want to read it from a media file like a video file, you can always put down the name of the file, name.mp4, whatever file name you have. But if you're reading it from your webcam like I am going to do now, I'm going to put down 0. If you have multiple cameras, put down 1 for the next camera, 2 for the third camera. And by default, it will use the 0, which is the most default camera in your system. So we'll create a video capture function like this, and we can start reading the images from it. We will create a while loop, So this is more like a infinite loop, which will continuously read images from the capture variable, from the video capture, and then display it for us. So we can do that by start reading the images, and we will read it on an image variable called img, and we will start reading the images coming out of the webcam. Now img is where the image coming from the webcam would be stored, and success is a flag. It is a flag which helps us know whether img came out properly or not. So if there was an error in the video.read function, the success flag will automatically become false or boolean 0. But if the img function or the video capture or the video read happened perfectly, then the success flag will automatically become true. So this is an Opencv methodology. It's something which is available for us to do some sort of debugging for our applications. So once we read the capture, now let's display it on our window so we know how it is running. And let's do it by using the cv2 imshow function. The imshow function takes 2 commands. One is the name of the window, and we will call it as invincible. And the second is the image that you want to display, which is the img. The cv2 imshow function does not work on its own. It does need a vidkey function, and for that purpose we would need a cv2 vidkey function. And what is a vidkey function? A vidkey function is something which takes some time. It tries to detect if there was any key press or if you want to give some sort of a delay, because the cv2 imshow function, it's the job of the cv2 imshow function is to display the image and then shut off. But if there is no delay or in the next task, or if there was something which is not holding the function, then the image will be gone. So for that purpose, we use cv2 vidkey function in order to display the image on the window. And you can put down 0 for infinite delay, or you can put down whatever delay you want. So in our case, we'll just put down 5. We will also set this function to look for a key press, and we'll say if the key press is Q, we'll ask the function or the program to shut down. So we'll also look for the flag, and it'll be 0ff. You don't need to worry about it right now. We're just trying to find out whether the person has pressed the Q or the escape button. And for that purpose, we will ask the function to monitor whether the person has pressed the word Q on the keyboard. And if Q equal to the key pressed, then simply come out of the loop, break the while loop, and then close the program. Before you close the program, you do want to destroy the window that you created, the CV2IM show invisible created, the window that you had created, you want to close that so that the memory is freed. And you do that by CV2 destroy all windows. And you also release your video capture. So this capture file variable, you want to release that as well. And you do that by video.release. And that's the function. So let's save this. Let's open up our command terminal and let's run this function. So you can see that it is running, and the image is simply reading the image from the video capture file, and it's displaying it for us here on the screen. So as simple as that. This is the basic functionality, just reading the webcam and then displaying it. So let's go to the next step. Now I'm just going to press the Q button on the keyboard, and the image should go away. So the program got shut down, and we are done with this. So the next step is, let's go back to our Python application. So far we are just displaying the image. Now, what was the invisible effect that we created? The invisible effect that we created is based on the zoom. It's called as a zoom. It's a combination of zoom and background removal. So you're doing background removal on your image, but at the same time, you're also doing a zoom effect, and you're replacing the new background with your zoomed version of the background. So you're replacing the background with wherever the foreground is, you're replacing the foreground with the background, but at the same time, you're replacing that foreground with a zoomed version of your background. It'll make sense in a little bit as soon as I start going into that. So the first step is, let's start into understanding how the background removal happens. So let's start doing the background removal. So we'll go into success video.read, and we'll initialize a flag variable. I'm thinking whether or not to do the zoom first or the background first. Let's do the zoom. That's probably much easier to understand, so that way I slowly increase the complexity of the application and not just go with that. So let's create a zoom effect. So zoom for effect will create a function called zoom and also crop. So you're zooming the effect, you're zooming the image, but also crop the image. And for that purpose, let's call image, and it'll take two variables, image, and we'll also pass in a scale variable. So we can say how much the image should be scaled or how much should it be zoomed. And let's take the information about the image, which is the height, width, and the channels information from the image. And this image is the image that came from the argument right here. So the image.shape function will give us the information about the image height, width, and channels. So once that's done, we will first crop the image. We will crop the image by the scale amount. Say, for example, the scale amount was 20 or 5 or 10 or 15. So that's nothing but pixel values. And you are telling the application to basically crop the image by the border by a value of 10, 20, 50 pixels, whatever the scale value would be. And for that purpose, we create a cropped image, and we do that by creating a region of interest. So I'm only interested in the region of interest, which is inside that cropped image, minus the pixel values. So scale equal to, and that's the scale which we are interested in. So we are starting from scale to height minus scale. So I'm telling that the Y value is anywhere between the 5 pixel and height minus 5 pixels. So say, for example, scale was 5, for example. So if the scale was 5 pixel, then I'm saying that the Y value is anywhere from 5 to height minus 5. And similarly, the X value is 5 from 5 to width minus 5. So you're just cropping the image. Let's change this 5 back to scale before we forget. And you are just cropping the image. So let me go back to this so we can see the image fully. Okay. So once we have the cropped image, so you have basically reduced the size of the image by the scale value. Now you want to bring that image back to its original shape. So it looks like it was zoomed or it was magnified. So that's the effect that we are trying to achieve here. Resized, cropped, equal to CV2 resize, and you're just resizing it. Resize the cropped image. The cropped image that we had to the original width and height. That's all it's going to do. It's going to resize the image to its original width and height. And once it's done, you just return the final output, which is the resized cropped image. And that's all this function is doing. So it's basically taking your default image. It is cropping the edges and then resizing that cropped image to the original size of the width and the height. So this is what it's doing. So it's basically, it gives out that zoom effect or that magnified effect on your background image. So let's come back here. So we will now use that zoom effect to create our zoom value, or we can try displaying it here. So let's see how we can use that information. So we have this function img, right? Img is the new image. So we will call, say, img or the zoomed img. Zoomed img equal to zoom crop, and we'll send the image img and we'll say a scale value of maybe 20. Okay, so we'll say 20, and we will also display this image again, show, and we'll call it as zoom, and we will call this as zoomed img. So now let's display both the images on our screen so we can see what's the difference between both of them. I have saved it, and let's open up the command prompt and let's read this. So we have zoomed and we have invincible. So it's a little bit difficult, but you can see if I move my hand towards the edge, how fast this one is moving, how much of a difference between both of them is. So you can see the my hand on the zoomed effect has already gone out of the screen, whereas the other one has not. So you can see it has zoomed a little bit. But let's queue this and let's close this and let's go back to our code, and you can maybe make it a little bit bigger so you can see the effect more enhanced. So let's make it a 50 and save it. Let's open the command prompt again and let's run this once again for ourselves. So you have invincible, and which is the regular zoom effect, and the zoomed image, which has the more zoomed. So you can see my face is already zoomed, and my hand, if I move towards the edge, you can see that my hand is already cropped in the zoomed effect, and here it's not. So it's basically having that effect where the image is cropped, and also, but at the same time, the size of the image, the aspect ratio of the image is the same. So that's what we wanted to achieve right now, and I'm just going to close this for now. Let's go back to our Python file and let's see what's the next step for ourselves. So we have the zoomed effect, we have the zoomed effect created for us. Now we will try to do the background removal effect. So let's do that. And in order for us to do the zoomed effect or the background removal, we do want a background image, and we'll say the background image is going to be coming from here. So we'll say the background, initially before, right when we open the webcam, let's capture the background. So we'll say success and ref img equal to video.read, and that's the function. And we'll also call a flag variable, And this flag variable will allow us to change the background during the running of the program. So we don't need to just wait during the beginning, but we can also change the background within the program itself while it's running. And we'll say that if flag double equal to 0, you want to change your ref image. You want to change your ref image to your current image. So you can replace your background at any point of time. And at the same time, you want to replace your image with the zoomed effect of the image. So we'll call it as replace. We'll call a replace image equal to zoom crop, and we'll send the background image, which is our ref image, and also let's give a scale value of maybe 20. So it looks not too cropped, but at the same time, it gives that decent effect of magnifying. So we have the ref image, and we created the zoomed effect now. Now let's create a mask. Create a mask for background removal. Let's do that now. So this step, we are trying to create a mask so that we can do background removal, subtraction. So let's first subtract the image. This IMG image would be your fresh image coming from the webcam, and the ref image will store the background removal image or the background image. And you want to subtract both the ref image and the IMG image. And for that purpose, we'll call a difference function, and we'll say cv2 subtract, and we will first subtract IMG minus ref image. So we are subtracting the foreground image, the new image, with the background image. And we'll also do another subtraction where we will subtract the background image from the foreground image. So the other way around. We're just doing two subtractions to avoid. We can also do the absolute subtraction, but for some reason I notice if I do two different subtractions, it is working out better. And I'm also going to add both the differences, so then we can use the better of the two. Add both the differences in a difference function. So this is nothing but the difference image. Let's make it a little bit bigger for you guys. Okay, once we have this available, once the difference is available, now we want to create that mask. And the way we can create that mask is by using the absolute value of the difference. And we'll give a threshold. We'll say if the absolute value of the difference is less than a certain amount, that should all become 0. So we're just creating that threshold that wherever the difference is less than so and so value, you should make that 0. That is nothing but your background. So you have found your background and the difference is not too big. So let's make that as a background. So in our case, let's put down 13.0. This is just a random file which I found. And the difference actually takes a square bracket, not the circle bracket, because it's not a function. You're just creating that threshold from within the function itself. So we are changing all those values to a 0 value. That's all we are doing right now. Now let's convert that into an image, because this is nothing but subtraction. So let's convert that into an image, and we can do that by using the grayscale function. Let's do that. Gray image equal to cv2 convert color. So once we have the flag, because this image is nothing but zeros and ones, and we are converting that into a grayscale image. We're doing that by cv2 convert color diff as type np unsigned integer 8. And now why are we doing this? This is because the difference image, it's nothing but zeros and ones. And in order for us to create that grayscale image, we want to convert that into an unsigned integer variable. So it's nothing but a matrix of images. So that is what we are trying to achieve right here. And once we have that done, we just convert the image CV2 color from BGR to gray. So you're bringing all the differences to a grayscale value. That's all what we're doing right here. And once we have everything set up, let's convert the grayscale into gray. Wherever gray NP is less than, wherever again the difference is less than a certain threshold value, we'll convert all those variables into 0. So let's convert gray NP absolute value of gray, or wherever the gray image is. If it is less than a threshold value, say for example 10, and it should convert all of them into 0. This all step is nothing but creating a mask, and it will make sense once we complete this part where we are going to create this mask. So first step we did was we subtracted the images, and the difference image or the subtracted image, we are trying to create a mask out of it so that we can remove all the noise from the image. So we are displaying the diff image and the grayscale image. So once we have this set up, the next step is to create that foreground mask for ourselves. The foreground mask is created by saying FG mask, and we'll first initialize image, and we'll say that it's type of it's the same shape as the grayscale image, and it's of the type unsigned integer of 8 bits. So once we have the mask created, we are saying in the mask, if anything is greater than 0, convert that into a 255, so it becomes white color. So you're changing everything which is of your interest, or which is the foreground, convert that into 255. So now we are creating a foreground mask. We also want to invert the mask, and we do that by invert the mask function, and we do it by using the bitwise not function. So what we're doing is we're creating an invert mask, and the reason for that is to again do our subtraction and addition of the images more easily when we are going to replace the images. So now we're creating an inverted mask, which is nothing but the background. So we do that by CV2 bitwise not. So wherever there is zeros, it becomes 1, and wherever there is 1, it becomes a 0. So we have the FG mask, and we have the FG inverted mask, which is the FG inverted mask right here. Now let's create our foreground image. The foreground image is the image that you want to replace in your video frame. So when you're displaying a camera, you have the background and you have the foreground. Now for our invisible man effect, you want to change or replace your foreground, which is me in this case, and we want to change that with the zoomed version of my background. And the zoomed version of my background is right up here with the replace image function. And you want the replace image, which is nothing but the zoomed version. We want to cut that image, just to take out the portion of the foreground, basically. Whatever I am representing in the image, that much portion I need to take out from the replace image, and the rest all is the same background. So it looks like I've basically enlarged myself with the background. So I'm blending myself with the background, but at the same time the background it's enlarged wherever I am. So it gives that effect that something is moving in front of the background. So let's open that. Hope it makes sense, and if you have any doubts, leave a comment. I can understand it can be a little confusing with the amount of inversions that we're doing here, but yeah, leave me a comment and I'll be happy to help you. So we have the bitwise underscore not FG mask, and the next step is to open up the FG mask. So now you want to extract the parts that we are interested in. Now use the FG mask and the inverted FG mask to extract to extract the foreground and the background parts. So let's do that now. So we can now create the foreground image, and the foreground image is FG image, and we will call it by using the bitwise and. So we can multiply one image to the other image basically, and that's all we are trying to do here. It's a simple function, and what we can do is replace our foreground with the zoomed version of the replace image, and you are going to be using 2 copies of the replace image. We're saying that it's you're using these 2 images and then saving it in the same one, and we are going to use the mask which we created earlier, which is the FG mask, and this is our FG mask. And similarly, the background image is going to be CV2 bitwise and we do that by the reference image, which is the regular background image, the ref background image, which is the original background image, not the zoomed image. And we are just converting. Now you're going to be using the inverted FG mask. That's all we have to do here. Let's not do any errors. So we have mask equal to FG mask. Once that is done, once we have this function written, now we can start displaying the image for us. So we have the foreground image and we have the background image. What is the whole image? The whole image is the destination image, or we can call it as DST, destination image. And we will say the destination image is nothing but the addition of BG image and foreground image. So we're just adding both the images, and so that they can mix and become one image for us. Once everything is done, now we are ready to display this image right here for us. Let's add a few more functions. Since we have this flag variable that we are using here, we can use this flag variable to convert or to capture new backgrounds whenever we need them. So whenever flag is equal to 0, it will capture a new background. So we'll use that same property for our purpose here. So we will say if someone presses maybe a D, let's say if someone presses a D, and if the key press was D, let's come back out of the bracket and let's say if the key press was D. So at that point, you want to make the flag equal to 1. And you can say print background was captured. So you're just printing it as a command prompt so the user knows that what happened. And let's say if someone pressed maybe R, so we can refresh, basically R for refresh. And you are looking for the key press, and if someone pressed the key R, then the flag equal to 0, so we can restart the capture. So we can say ready to capture. So that's just letting the user know that it can be ready to capture the images. So we have everything done, and if we press Q, it comes out of the program and it runs and displays the image for us. Let's see if we can do anything else on this application, anything else that we might be needing. I think we have achieved everything. Let's try to run this application and see how it works. And if there are any errors, we can try to fix them. Okay, let's open up the command prompt and let's run invisible man. And there is an error numpy at the grayscale image. So let's see why we're getting that. It's probably not reading an image or not getting an image. So let's come back to our code and see what is not working. So we have this, and it was giving an error and this function. So it's saying that diff unsigned integer is not. Let me make it a little smaller so it's easy for me to debug and read everything. And let's see where we are doing that mistake. So we have the threshold, so you're getting the diff value. Of course, you have an image, and you're also creating a diff image, and you're also reading the image. So let's see what could be the error. I'm sure some of you might have seen my error already, and I wish this video was running in live mode so I would know what the error was from you guys already. But let's see what's happening here. We have the image, we have the ref image, we're also using the img image. Everything seems to be fine. We're also converting the img image from here, and it looks like we are reading everything properly here. Let's go back into the command prompt and see what was the error. NumPy has no attribute. Oh, that's a typo. It should be uint. Okay, that's my error. Sorry about that. We just need to remove the n, and we also need to remove the n from here. So it's uint, basically unsigned integer. And now we can save this, and let's open up the command prompt and let's run this code. So it should open up now. It should open up a browser image for us. Okay, so it's starting to read. So let's see what happens if I press, say, D. So when I press D, it'll capture the background. I'm looking into two screens because I have two screens, one the code and one where the webcam is available. So I'm basically pressing D, and it'll capture the background right here. Let's capture the background, and if I move, oh, it's not capturing the background, it's not displaying, it's not subtracting. So let's see what kind of an effect it is. If I press R, and it's ready to capture. So it looks like it's not working the way we wanted. So let's go back and see what we need to change in our code. Come back here, and we basically saying that if the flag is 0, your reference image is img, and if I press, the flag is 0, okay, and if I press D, the flag becomes 1, and let's basically print the flag also, so we know what kind of a flag we are going to be running. This is just debugging ourselves, and we should print the flag. Let's do this. Print flag, so we can see whether it's converting it to a 0 or a 1, and it should be doing it right now. So we have everything working properly. Let's see what the error could be. Yeah, this is not the fun part where you have to find your own mistakes and try to solve them, especially when you're trying to record a tutorial. But this is what debugging is. This is how we can fix things. So let's go back and see why the function is not working properly. And let's print this. Let's start running this. So it should open up a window for us. And okay, so the window is created here. And we are ready to rumble. So if I press D, it's saying video is captured, but nothing is capturing. It's not even printing the flag. Why is it not doing that? Let's go back. Flag is equal to 0, and we're changing flag equal to 0 here. Ready to capture, ready to 1. And we are also doing flag right here. Oh, you know what? I did not even save this. Let's save this and let's rerun this. Stupid mistakes man can do, especially when recording a video. Okay, so the flag is being printed as 0. And the moment I press D, it's capturing. Okay, so the flag is changing as we want. Again, if you press R, it becomes 0. And if we press D, the flag becomes 1. So it is working. The command prompt is properly reading the images for us. But what could be, what is probably causing it not to go through the process of replacing the image? So we have flag equal to 0, and we are calling the ref image. Ref image is equal to img, and we are also replacing the image by the zoom effect. Of course, the zoom effect is created nicely and it's working properly. But why is it not replacing the background for us? Are we missing something? Let's come back here. Diff function is working properly. The ref function is working properly. This function is working properly. I don't know. If you guys are interested in watching my debugging, I can always skip this and just show you the final output. Now I can find the mistake on my end and then let you guys know what the mistake was. Which is better? Should I do that or spare this issue with you guys? You can always download the code from the GitHub repository in the description and try running this on your own. But at the same time, if you are interested in, if it's something you're interested in, to know how I debug and how I try to find mistakes, if it helps you, leave me a comment, and I'll in the next videos that we make, I'll leave the debugging portion for you guys to see. So we have the replace image. We're replacing the replace image, the foreground, and the FG mask. So that is fine. So this seems to be working properly. And we have the FG mask inverted, where we are using it for our background image. So that seems to be fine. We are also adding you know what, I found it. We need to display the destination image instead of the img. That was a stupid mistake. So once we have everything done, instead of displaying the DST image, I was simply displaying the img image. So that is the error. We can also spare the printing of the flag to avoid. Let's go back. Let's clear this. Let's go back and run this. So it should open up a browser window for us. And if I press D, it will capture the background with me. And you can see the new me is now trying to move in front of the old me. So this is basically what we are trying to achieve. So it captures the background. Let me press R. So I'm coming back here. I'm just moving in from the camera. So basically, when I press D, it will capture the image, it will capture the background, and at the same time, we will start doing the background subtraction and replacing the background or my foreground with the zoomed version of the background. So it's all happening in real time right now, and you can see how efficient and fast this algorithm is working. So you can see how I'm changing. Right now I'm back on capturing the background, and then if I press D, and it will start doing it like this. So we have all our invisibility effect done. So with that, we come to the conclusion. If this video is something that you're interested in, if it helps you, or if it's something, I don't know how you would be using this application, but if it does, let me know. And let me know what kind of a project you are interested in, what you want me to work on. What is it that you want me to get into or start making tutorials on. So let me know whatever you are interested in, and I'll be happy to look into that and try to work on it myself. So with that, take care, stay safe, bye-bye.